Yeah, when we talk about GETs, we are essentially talking about multiple different technologies. So DLR is like one of them, power flow controllers is another one, topology optimization is another one, and then even advanced reconductoring can be considered as an alternate transmission technology or GETs. So one of the challenges, if you look at it from a broader perspective, is a lot of these technologies, let's say topology optimization or power flow controllers, I mean, you need to actually plan the grid to have these kind of things in operations later on. So it's a planning problem and it's an operations problem both. And if you do not have the software that can actually model these different types of grid enhancing technologies that I just mentioned and figure out the impact of that on a system-wide level, because the power systems is a non-linear system, it's a macroscopic system. You do something here, the impact will be somewhere else. How do you kind of evaluate those impacts of the GETs? And then figure out that it's not just about modeling the GETs, it's also about optimizing the grid using different types of GETs and coordinating all these different types of GETs and get a combined win or a combined impact. Now, how do you do that in planning? And then how do you do that in operations? And that is where what I strongly believe is that is where software plays a big role. If the conventional software does not have the ways to model these, and not just model, but also to optimize different types of GETs and coordinate each of them and find out the different permutations and combinations of the solutions, that's a missing piece right now that I feel should be filled up. I mean, if the software can be looked more as a decision support mechanism in both planning and operations, I think the adoption of GETs can be broadly increased. So I think that's a missing gap that we see as well. And that's where Grid Astra tries to play a big role with the kind of software that we are trying to have.
Yeah, thanks.